Hi, welcome to this section, plotting charts with images and maps. In this section we're going to first learn plotting with images and then display images with other plots in the figure. We'll also plot data on a map using Basemap and finally generate capture images. Now we move on to the first video of this section that deals with plotting with images in Python. In this video we'll use images to highlight the strengths of your visualization in addition to pure data values. For this we'll first create a figure and load its data using CSV module. We will then instantiate the CSV reader object and iterate over the data. Finally, we'll compute the zoom coefficient to scale the size of the image. Images can be used to highlight the strengths of your visualization in addition to pure data values. Many examples have proven that by using symbolic images we map deeper into the viewer's mental model, thereby helping the viewer to remember the visualizations better and for a longer time. One way to do this is to place images where your data is, to map the values to what they represent. The Matplotlib library is capable of delivering this functionality, and here we demonstrate how to do it. Here we'll use the fictional example from the story The Gospel of the Flying Spaghetti Monster by Bobby Henderson, where the author correlates the number of pirates with the sea surface temperature. To highlight this correlation, we'll display the size of the pirate ship proportional to the value representing the number of pirates in the year and the sea surface temperature is measured. We will use Python's Matplotlib library's ability to annotate using images and text with advanced location settings, as well as arrow capabilities. For example, this code shows how to add an annotation to a chart using images and text. Here we have defined the helper functions so that we can approach the construction of the figure object and add subplots. We annotate these for every year in the collection of years using the image of the ship, scaling the image to the appropriate size. Then we start by creating a figure of decent size, that is 16 by 8. We need this size to fit the images we want to display. Now we load our data from the file using the CSV module. So by instantiating the CSV reader object, we can iterate over the data from the file row by row. Note that the first row is special, it's the header describing our columns. As we've plotted years on the x-axis and temperature on the y-axis, and we read that with this code of line. X label, comma, Y label, comma, underscore equals header. And here we plot it by using these lines. Next, we return the header and data rows lists from the load underscore data function to the main caller. After this, we use the format underscore data function and read every item in the list and add each separate entity, the year and temperature and number of pirates, into the relevant ID list for that entity. So the year is displayed along the x-axis while temperature is on the y-axis. The number of pirates is displayed as an image of a pirate ship, and also to add precision, the value is displayed. We then go on to plot year and temperature values using the standard plot function, not adding anything more, apart from making the line a bit wider, that is 2 point. Next we proceed to add one image for every measurement and to illustrate the number of pirates for a given year. For this we loop over the range of values of length, plotting one black point on each year or temperature coordinate. Next we load the image of the ship from the file into a suitable array format using the readPNG helper function. We then compute the zoom coefficient to enable us to scale the size of the image in proportion to a number of pirates for the current measurement. Here we also use the same coefficient to position the image along the grid. The actual image is then instantiated inside offset image, which is the image container with relative position to its parent, i.e. annotation box. You must be wondering, what does this annotation box do? So, annotation box is an annotation-like class, but instead of displaying just text with the axes.annotate function, it can display other offset box instances. This allows us to load an image or text object in annotation and locate it at a particular distance from the draw point, as well as allowing us to use arrowing capabilities to precisely point to an annotated data point. Here we supply the annotate box constructor with certain arguments, which you can see in the code. First is the image box. This must be an instance of offset box, for example, offset image. It's the content of the annotation box. XY is the data point coordinate with the annotation relates to. XY box defines the location of the annotation box, then follows the XY coords, which defines what coordinating system is used by XY, for example, data coordinates. Next is the box coords to define what coordinating system is used by XY box, for example, offset from the XY location. Pad specifies the amount of padding, whereas the arrow props is the directory of properties for drawing an arrow connection from an annotation bounding box to a data point. Finally, we add text annotation to this plot using the same data items from the pirates list with a slightly different relative position. Most of the arguments of the second annotation box are the same. We adjust XY box and pad to locate the text to the opposite side of the line. The text is inside the text area class instance. This is similar to what we do with image, but with text.time.textArea and offset image inherit from the same offset box parent class. We set the text in this text area instance to no pirates and put it in our annotation box. So let's run this code and see the output. As you can see, you get the image of pirates plotted with the data, making your data visualization easier. Awesome! In this video, we've plotted the data with images to enhance the view and visualization of the viewers. In the next video, we'll see how to display images with other plots in the figure.